Welcome back to the Math Professors. The material we cover can be found in any college math class. Today I'm going to do statistics, but you can find algebra, calculus, and so on. So if you like the free content, please consider liking, subscribing, and sharing. So today I'm going to show you how to use a z-score table, but first I want to explain what a z-score table looks like and really what it means. So what I want to do is kind of go back to a discrete probability distribution. And so let's consider this discrete probability distribution. What we know about that is, this is numerical. This column adds to 1. All these things are probabilities because they're between 0 and 1. So this is, a probability distribution. Now, we can also rewrite this as a cumulative probability. Really what it means is the first one is going to be, 0.21. Now, really what I mean by cumulative, this means anything, 1 or less. So what I'm going to do is I'm going to add these two things together, which is going to give me 0.55. Now this is not the probability of 1. This is, everything less than x. So, the sum of all values less than x. Now at 2, I'm going to add this 0.29, which is going to be 0.84. And then finally, I'm going to add this 0.16, which is going to be 1.00. So since it's a probability distribution, we knew that it added all up to 1. And you can see actually that the sum of everything that is 3 or less is equal to 1. So when we're looking at a z-score table, what you'll notice is the values inside the body of the table, they get bigger and bigger and bigger until you see like 0.999. And then they say anything bigger than, I think, 3.5, they just say consider, 0.999. And if they get even bigger and bigger and bigger, you can see that they're going to get closer and closer and closer to 1. Okay, so let me pause this. I'll kind of show you what a z-score table looks like and then how to read it. So here's a partially filled out z-score table, and this is going to be a positive z-score table. And you'll know it's positive because right on top it will actually say a positive z-score table. And then they'll also say that this is cumulative area from the left. So it'll say positive up here, and it'll say cumulative area from the left. And what they mean by that is these are accumulations of probabilities. So at z-score, which is equal to 0, we're going to have 50%, and let me kind of explain what that means. So when we're looking at our probability distribution, our bell-shaped curve, our standard normal distribution, we know that it's got a mean of 0 and it's got a standard deviation of 1. So, these are going to be z-scores. Now, if I'm asking what is the cumulative probability all the way up to 0, I'm really asking what is the summation of the probabilities all the way to 0. So we're asking for this part here. Now, since I know that this is a probability distribution, the entire bell-shaped area is going to be equal to 1 because that's the sum of the probabilities, just like the discrete probabilities, that column adds to 1. Except this is continuous now, so all these probabilities, the infinite amount of probabilities, are going to add to 1, and if I go halfway, I can see that I get a probability of 50%. Now, as you keep going further and further and further, at the z-score of 0.01, we can see that this is going to be a little bit bigger than 50%, and so on. So what if I want to find, say, the probability of, say, this one? Let's go. What if I want to go to, say, 1.28? 1.28. How do I calculate this, the probability of a z-score being less than 1.28? So let me make sure that we really understand what this means. What this pink area really means, this is the probability that your z-score is less than 0.00 or just less than 0. Now the reason why it's 0.00 is because when you read a z-score table, these are going to be the first two digits, which happen to be right here, 0.0. That comes from this column. And then this last 0 right here comes from this top row. So you can see that 0.0 plus 0.00 is going to give you that 0.00, or just 0. Now if I want 1.28, what I know is the first two numbers are going to be 1.2. So I go down to, I find this 1.2. Now what I'm going to do is I'm going to slide this to the left. I know I'm missing a lot of numbers here, but I need to fill them out. I just need to show you some of them. And the idea that this is cumulative. It increases. It gets bigger and bigger and bigger as it gets closer and closer. It gets closer and closer to, to 1. So 1.2 here. I need 0.08 here. When I map these things down, I can see that that probability, the sum of the probabilities all the way up to that 1.28, is going to equal this 0.997. So that's what this area is. Like this area was 0.5000, 0.5000, or just 0.5. Now the probability that your z-score is less than 1.28 is going to be equal to the area in here, which happens to be this 0.8997. So 0.8997. Now what the table does a great job of is it gives you area to the left. So that's all it can do for you. So if you need to find area to the right, you're going to have to get clever with this. So what if I ask you, what is the probability that the z-score is to the right of 1.28? Really what I'm asking for is what's this area in here, that missing area. Now since the sum of the probabilities is equal to 1, what I know is that if I want to find the probability that z is greater than 1.28, I know since the entire area is equal to 1, I just have to take 1 minus this area to the left, which is going to be 0.8997, which is going to give me 0.1003. So you have to get clever with your z-score table. It only gives you cumulative area to the left. So let me put a couple examples on there. I will show you the value of the table, and then we'll talk about how we go left and how we go right and how we go between. All right, so here are 4 examples. So it says use the z-score table to determine the probabilities. Also draw a picture of the standard normal distribution and shade the appropriate region. So the first question is asking, what is the probability that z is less than 2.33? I'm going to draw the region first. It helps me understand what I'm to expect as far as our probabilities. Am I going to get a probability really like bigger than 50%, less than 50%, and so on. Now again, the standard normal curve has a mean of 0, so a center of 0, and then each one of these are going to be a length of 1 because it has a standard deviation of 1. So this is going to be 1, this is going to be 2, -1, -2. Now you don't have to draw it every single time. I just want to know, where does 2.33 live with respect to these numbers? Well, 2.33 is going to be a little bit bigger than this 2, so I'm going to say right about there is my 2.33. So I need to find this shaded region. So what I'm asking for in this case is, what is the probability that z is less than 2.33? Now what's nice about your z-score table, and what they look like in your book, is something like this. What you'll see is a negative z-score table and a positive z-score table. These are going to be the z-scores you're going to have to. These are going to have to be the z-scores you're going to line up. So the first 2 digits and then the very last digit, and then you just kind of work your way to the middle. So the body of the graph is going to be your probabilities. So in order to do 2.3, what I know is I'm going to have to go down to 2.3 on this list, and then in order to get this last 3 over here, I'm going to have to go to 0.03. So then I'm going to work them together to find that number. So on the table, you're going to go down to 2.3, and over here you're going to get 0.03, and then you're just going to reach this center number, which is going to give you 9901. So that's our probability. So this area in here, I should have did it in pink, but that area here, this is your probability, this number right here. So that probability, this area is equal to 0.9901. Now let's do this for the negative. So if I want to do the negative, I'm going to draw the standard normal again. I like to do the distribution curve in a little bit of color. So I know that the center is going to be equal to 0. I'm not going to do every dot. So that means negative 0.61 is going to be over here. So negative 0.61 being somewhere about here, 0.61. So again, less means I'm shading to the left, so we're talking about this area here. And this area is my probability. That's what that z-score table does. It gives you areas which are also probabilities. It's the sum of the probabilities. All right, so the probability that z is, I'm going to do this in pink because that thing means probability, which means area. So the probability that your z is less than negative 0.61 really just means I have to, again, on the z-score table, over here on that left, it'll say z up here. I need to go down to negative 0.6, so I'm going to be in the negative table, so I'll be the table on the left. So I'm going to go to negative 0.6, and then I also need the 0.01, so the first one will be 0.0, the next one will be 0.01. And then I'm going to take that to our probability, which I'll find right now. So this is going to be 2709, so that's going to be our probability. this area in here is 0.2709, so that's what this is equal to. So this is equal to 0.2709. All right, let's make sure that these things make sense. Well, I know that I'm going to z-score above 2, so I know I'm going to get, most of this. That 95% of the area is supposed to live between -2 and 2, or at least about that. So this is going to be most of, your data, or 99% of your data is really what that means. So if you want to put this in percentage, just move the decimal place twice, so that's going to be 99% of your data. Now, this is less than half of your data because it's below that 0. And, almost, not quite to -1 standard deviations or 1 standard deviation below. So we can see is that this is going to be 27.09% of your data. All right, so let's do it for more. If I want to do it for more, what I'm going to have to still do is find this number on your z-score table. And more, we know that it's going to be area to the right. So if I was going to ask for more than this number, if I want to find this missing area, it would just be 1 minus this number. So we're going to have to do the same thing over here. So let's go ahead and draw the picture. Standard normal, center of 0. 1.08 is going to be, this is 1. So I'm going to go a little bit farther. So let's say this is 1.08. So I know I'm going to have to find the area of that thing. Now I have to be careful because remember, your z-score table actually gives you this area. It always gives you cumulative area to the left. So I have to be careful. The more is actually this area here. So let's find this area and subtract it from 1. So what that means is the probability that z is greater. Let's do this in a different color. So the probability that z is greater than 1.08 is going to be equal to 1 minus this pink, which is the probability that z is less than 1.08. So this is going to be equal to 1 minus. Now again, we look at 1.08, so I'm going to have to do 1.0 on the vertical and then 0.08 on the horizontal. So pause it. What we get is we get 8599 for this area right here. So if this is 0.8599, then since the entire thing adds to 1, this area over here is going to be 1 minus the pink area. So this is going to be equal to 1 minus, which gives me 1401. Now I'm supposed to shade the appropriate region, so since this is in green, I'm going to shade this region right here. And if I was going to do this on a test, I would kind of erase that pink. So I'm going to do that right now. The pink is not what I'm trying to shade. What I need to know is what's the probability that I'm greater than that 1.08. So that's going to be, the 0.1401. Now, if I want to do this between, we're going to get a little clever. Let me erase it so I can show you how to do the probabilities. Just an image of what's going on. All right, so I wanted to find the probability that z is between this -2 and +2. And let's go ahead and draw the picture over here so we can see what we're trying to accomplish. So here's going to be our distribution curve. We know that the thing is centered at 0 here. So that means -2 is going to be somewhere over here, and +2 is going to be somewhere over here. So what I'm trying to do is I want to find the area between these things. So I need to find, this area here. Now remember that your z-score table only gives you area to the left, so I have to get a little clever in order to find that. So this is my answer. So in order to do this, what we do is we take the area to the left of 2. So if I start with 2, my table will give me this answer. It'll give me the cumulative area to the left. The problem is this is not what I need. What I'm looking for is, I'm looking to get rid of this left-hand tail. So what I'm going to do is I'm going to subtract off the area to the left of -2. So -2 being right here. So I'm going to subtract off this tail here. So we can see is if I have this area and I get rid of that tail there, so this area, get rid of that tail, is going to give me this cumulative area between, which is the way we're going to have to do with our table, since tables only give you area to the left. So let's find these particular areas. So I guess I'll do them in pink. So this particular area right here is going to be, this is the probability that -2 is less than z, which is less than 2. So that's that cumulative area right there, which I know is going to be equal to the subtraction of these two areas. Well, this area is the probability that z is less than 2, and this is the probability that z is less than negative 2. And I'm going to have to subtract these things. So again, when we go on our z-score table, if I want to find this one, what I need to do is I have to go all the way down to this says 2.0, and then the first column is going to be 0.0. So if I'm looking for 2, I'm actually looking for 2.00. So it gives 0.9772. Now similarly, on the negative z-score table, I have to drop this down to negative 2.0 and also 0.00. So this will give me my negative 2.00, and that 228. So these are these two probabilities. That's this one, and this is going to be this one. So I'm going to have 0.9772, and I'm going to subtract off 0.0228, and this is actually going to get me my target probability. So 0.9772 minus 0.0228, which is going to be 9544. So this is 0.9544. Now, at the beginning of your statistics classes, we always say, you know, the area between -2 and +2 standard deviations is about 95%. And the reason why they say it's about 95% is because it's actually slightly bigger. This really represents 95.44%, but you know what? About 95% is good enough for the beginning of class. So please, again, consider liking, subscribing, and sharing.